Hello and welcome to Uncle Maths Online Academy. Today we have basic science and we are going to discuss power. In the previous class, we talked about work. We explained the concept of work, the unit of work, and how to calculate work done by body. Today we are going to discuss power. Power means how quickly a work is done. How quickly we perform our work is what we call power. In formal definition, or to define it in a formal way, we say that power is work per time. Work per time. That is how quickly work is done. If I'm given the same load, maybe a block that weighs 20 gram, we have two blocks that weigh 20 gram, and me and you, we are asked to carry it and take it to the same place. If I take my own to the place before you get there, then it means that I have more power than you because I carried the load and moved it to that place that is doing work. Work is load times distance or force times distance. So I moved my load to the place before you. That means that I completed it at a shorter time than your own. That means that I have more power than you. That is what we mean by power. Power means the rate of doing work. That is the definition. Power is defined as the rate of doing work. If somebody asks you to define to define power, you say that power is defined as the rate of doing work. If we are talking about rates in mathematics and physics, we are talking about how quickly that thing is done. That is, we are talking about that in relative to time. In relative to time, we are comparing it with time. We're comparing the time that thing is done. That is what we call rates. The rate of doing work means we are comparing the time of doing the work. That is the rate I'm doing my own work with the rate you are doing your own work. That is what we call power. How quickly a work is done is what we call power. So the mathematical expression or the formula for work is, for power is equal to work, which is W, over time. Power is equal to W over time. And we know that the unit of our work is what? Joules. So it is joules, then joules over time is measured in seconds. So it is joules per second. If you have something over something, we say that it is that thing per. So joules per. The division becomes per. So joules per second. That is the unit of power. So let me define power. Power is defined as the rate of doing work. Full stop. Power is defined as the rate of doing work. Units. The unit of power is joules per second. Instead of writing it this way using a division sign, we can combine it and write it that the unit can also be written as joules joules second raised to power minus 1. Now, remember that we can abbreviate joules to J. The same way, we can abbreviate second to S. So the unit is also J per second. If we want to remove that division sign, we write that symbol and write raised to power minus 1. So this thing is the same thing as J over S. This is joules per second. Now, we can get other formulas from the formula of power. Now, since we say that power is equal to work over time, now remember that in the other class, we said that work is equal to force times distance. So we can use this force times distance to replace W here. So, and then we divide by time. Yes. So if we are given, there is a case that we may not be given the work direct, but they will just give us the force and distance. So if they give us force and distance, it means that we have to use the force and distance given to us to calculate the work and now divide it by time to get the power. Even the force, I said that if we don't have force, we can use F equal to MA to get the force. That means that sometimes they may not even give us the force straight, but give us mass and then acceleration and then give us the distance. Then we use the three things to calculate the force and then times by the distance to get the work. Now this can also be equal to mass times acceleration times distance now over time, because MA is equal to F and then times by distance. So these are different ways that we can express work. These are different ways that we can express work, the formula for work. Now let's solve some examples. Example 1. Example 1. Now calculate the power. Calculate the power of a machine. Calculate the power of a machine if it performs 300 joules of work in 2 seconds. If it performs 300 joules of work in 2 seconds. Now, solution. Power is equal to work over time, which is equal to work is given to us as 300 over time is 2 seconds over 2, which is equal to 300 over 2 is equal to P is equal to 150 joules per second. Now this unit, we can remove this unit and put what we call watts. Watts is used more often than this joule per second. So another unit for power is watt, and it is the common unit for power. So instead of writing joule per second, we can just write it as 150 watts. 150 watts. WATTS. It is the common unit for power. watts. Example 2. Example 2. Calculate the power spent by a boy if he moved a load of 10 Newton to a distance of 2 meters in 5 seconds. Now, how do we do this solution? We know that power is equal to work over time. Now, but here, work is not given to us straight, but we are given the load and distance. If you have load and distance, we can calculate work, because work is equal to F times D, which is equal to the load is 10 times the distance moved is 2 seconds. A load of 10 Newton to a distance of 2 seconds, 2 meters, to a distance of 2 meters. So 10 times 2. So we are now going to have that power is equal to work over time, which is equal to 20 over the time is 5 seconds. 20 over 5. Power now is equal to 20 over 5 is 4 joule per second, or 4 watts. So in case they write it as 4 watts, you know that watt is also the unit of power. And if they write joule per second, you should also know that joule per second is also the unit of power. In case they ask you to write the unit of power, write joule per second and write power and write watt if you can remember 2 of them. If you cannot remember 2 of them, write any one you can remember. You write either joule per second or you write the watts. Example 3. If you have calculate the power of a machine. Calculate the power spent. Calculate the power spent by a boy if he moved a load of 20 gram. If he moved a load of 20 gram to a distance of 2 meters in 4 seconds. Now look at this one. Here we have a load of 20 gram. Gram means that this is talking about mass and not the weight. It is talking about the the mass and not the weight. Weight is measured in Newton, that is N, but mass is measured in gram, which is G. Now to convert mass to weight, we times it by 10. Like I told you in the previous class, if you have mass and want to convert it to weight, we times it by 10. So what we are now going to get, solution, our weight is equal to 20 gram times by 10, which will give us 200. Now we now have weight and we have distance. If you have weight and distance, that is load and distance, we can calculate force. The distance is 2 meters, 2 meters. So we use this 2 to calculate the force. Force now is equal to weight or the load times distance, which is 200 times by 2, which is 400. This is the force. Now that we have our force, we can times it. We have our force here, so we now divide it. Sorry, this is the load. The weight is the force. Now that you have force, this is power. Now that you have our weight, now you can convert the weight to power by timesing it with the distance. And so power to work by timesing it with this distance. This load is not work, this is F. F is equal to mass times acceleration, and we now have our work. Work is the force, which is 200 times by the distance moved, which is 2. So the work done is 400, and now power is equal to work over time, which is equal to 400 over the time is 4 seconds. In 4 seconds. So we are now going to have 100 joule per second, or 100 watts. Watt is also represented with the symbol W. So 100 joule per second or 100 watts. So here we first of all converted the mass given to us to force or to weight by multiplying with 10. Force is equal to mass times 10. We get 200. Now we convert the force to work by multiplying with the distance, which is 2. So it becomes 200 times by 2 to get 400. And now from the work, we convert it to power by dividing with the time, which is 4. It becomes 400 divided by 4, then we get 100. So this is how to calculate power using different methods. So we've introduced the concept of power, the units of power, and then how to calculate power in this class. Thank you.